What is the Domain Name System, DNS?
DNS is a hierarchical and distributed names service that provides a naming system for computers, services, and other resources on the Internet or other IP networks.
I assume the viewing audience is already familiar with what DNS is, what it does, and how it basically works. Therefore, we'll focus on installing and configuring DNS on Windows Server and Linux platforms. Since Active Directory relies on DNS, it automatically installs and configures AD integrated DNS on domain controllers. However, for this demonstration, we'll install a standalone Windows DNS instance that relies on DNS zone files, closely matching the configuration of a Linux DNS installation. Our DNS servers are Windows Server 2025, Ubuntu 25.04, CentOS Stream 10, OpenSUSE Leap 15.6. Initially, we will set up a simple caching-only DNS server that will forward inquiries to an upstream DNS server. We will install it using both the GUI wizards and PowerShell. When complete, we will test from a client configured to use our new DNS servers. Later, we will add and configure domain zones. While logged in with local administrator rights in Server Manager, at the dashboard, click Add Roles and Features. Under the Server Roles section, select DNS Server. Leave the Include Management Tools checkbox checked and click Add Features. Click Next twice. At the DNS Service section, take note of the notes. Click Install at the Confirmation section and close the wizard when complete. Open DNS. Select the server, right-click, and select Properties. Interfaces tab. Listen on all addresses or select specific addresses as required by your needs. Forwarders tab. Click Edit and add 8.8.8.8 as a server-wide forwarder. Later, we will specify a different forwarder for a specific zone. Under the Advanced, Root Hints, Debug Login, and Event Login tabs, note the default settings. Monitoring tab. Select both a simple query and a recursive query checkboxes and click Test Now. Both should pass. Although installing the DNS role automatically configures Windows Firewall, it's still a good idea to check. Open Windows Defender Firewall with Advanced Security. Under Inbound Rules, ensure DNS is enabled for all connection profiles. We can also install DNS using PowerShell. Open an administrative terminal or PowerShell session. If using Windows Server Core, select option 15. Install using the Install-Windows feature commandlet, specifying the DNS role and including management tools. Add a forwarder or forwarders using the Set-DNS Server Forwarder commandlet, specifying the forwarded IP addresses separated by a comma. Verify forwarder settings with Get-DNS Server Forwarder. Use the Get-DNS Server commandlet to see all information about the DNS server. The Get-DNS Server settings shows basic settings. Perform a basic test using Test-DNS Server and specifying the server's IP address. Check the inbound firewall rules using Get-Net Firewall rule for the DNS service display group. From a Windows client configured with our DNS servers, look up and resolve any public domain name. Likewise, do the same from a Linux client. For a standalone Windows DNS server, the DNS files are located under C:/Windows/System32/DNS. Since we don't have any zones yet, there are only a couple of files. the cache.dns file contains the root domain name servers. The samples folder contains just that, samples. The 192.dns file is an example reverse lookup zone file. However, it contains some helpful information about pointer records. The place.dns file is an example forward lookup zone with helpful commented lines. Although the boot file is typically not necessary for a Windows DNS server, it is worth a look. For Linux, the Berkeley Internet Naming Daemon, bind, is the most common DNS server application. At a terminal, for Debian or Ubuntu-based distributions, use apt to check if the necessary packages are available. Install bind9, which will also install bind9-utils. Once complete, check to see if the service is started. By default, the new DNS server will use the root hints for public name resolution. So we're going to do like we did with Windows, set up forwarders to specific DNS servers. Change directory into /etc/bind. Edit the name.conf.options file, uncomment the forwarder lines, and add the upstream forwarded DNS IP addresses. Restart the bind9 service. From a Windows client system configured with our Ubuntu DNS server, look up and resolve any public domain name. Do the same from a Linux client system also configured with our Ubuntu DNS server. For whatever reason, Debian Ubuntu does not install a local firewall by default. Depending on your environment, this might be a desired behavior. But for this demonstration, we will install the Firewall D service. If running Ubuntu with a GUI, install the Firewall D and firewall-config packages. If running Ubuntu with only a terminal, you only need Firewall D. Although Firewall D automatically allows inbound SSH, port 22, connections, practice caution when performing these actions remotely. Following the installation, check the service status. Now back at a client workstation, try to resolve a public domain name. Notice how name resolution using either NSLOOKUP or resolve-DNS name will time out on Windows clients. On Linux clients, name resolution using either NSLOOKUP or DIG will flat out fail. Back at the Debian Ubuntu DNS server, using Firewall-CMD, allow inbound DNS traffic by adding the service to the permanent configuration. Reload the firewall service. If logged in via a desktop environment, you can use the firewall application to check the status. Check to see that DNS is checked for both the runtime and permanent configurations under the public zone or whichever zone is active for your environment. Test again from both the Windows and Linux clients and observe successful name resolution. For Debian Ubuntu systems, the DNS files are located under /etc/bind. The db.empty file can be used as a template for the forward lookup zone, and db.127 can be used as a reverse zone template. Although Red Hat and its downstream clones also use bind as the default DNS server application, the installation procedures differ significantly enough to warrant their own attention. At a terminal, for a Red Hat-based distribution, use DNF to check the necessary packages are available. Notice the package is bind, not bind9. Install bind, which will also install any necessary dependencies. Once the installation is complete, check the service status. In Red Hat, the DNS service is named, and not bind as you might expect. Notice that the name service is inactive and disabled. Although a DNS server is installed, it is not usable at this point. Change directory into /etc. Make a copy of the name.conf file and open it for editing. For this demonstration, I commented out both listen on lines to allow the DNS server to listen on all assigned IP addresses. Likewise, you can use the keyword any to accomplish the same thing. I have added my local subnet to the allow-query statement, and I have added the forwarder statement with the upstream DNS server IP addresses. When complete, use the name-checkconfig command to verify the configuration file. And if the command displays no output, the syntax is correct. Red Hat distributions, by default, install and configure the Firewall D firewall service. Using Firewall-CMD, allow inbound DNS traffic by adding the service to the permanent configuration. Reload the firewall service. If using Server with a GUI, you can optionally install the Firewall-config package. Using the Firewall GUI application allows easy viewing of the firewall configuration. Enable and start the bind named service. Check the service status. From a Windows client system configured with our Red Hat/CentOS DNS server, look up and resolve any public domain name. Do the same from a Linux client system also configured with our Red Hat CentOS DNS server. The location for the name.conf file is in /etc. All other config files are located in the /var/named directory. However, only the root user can navigate the folder and view the contents. The folder /usr/share/doc/bind contains a README file. The sample/etc and sample/var/named subfolders contain example sample files and are readable by everyone. The installation of the DNS server service for SUSE is similar to Red Hat, but again, the differences warrant separate attention. At a SUSE terminal, use zipper as root to check if the necessary packages are available. Likewise, you can use the YAST Control Center, Software Management, and search for bind. Like with Red Hat, the package name is bind. Install bind, which will also install any necessary dependencies. Change directory into /etc. Make a copy of the name.conf file and open it for editing. And again, we have a different default format because reasons. Make a note of the working directory. For this demonstration, I have uncommented the forwarders line and added the upstream DNS server IP addresses. When complete, use the name-checkconfig command to verify the configuration file syntax. Like Red Hat, SUSE, by default, installs and configures the Firewall D firewall service. Using Firewall-CMD, allow inbound DNS traffic by adding the DNS service to the permanent configuration. Reload the firewall service. If using Server with a GUI, you can optionally install the Firewall-config package. Enable and start the bind named service. Check the named service status. From both a Windows and Linux client system configured with our SUSE DNS server, look up and resolve any public domain name. The location for the name.conf file is in /etc. All other config files are located in the var lib named directory, and it is readable by everyone. The folder usr share doc packages bind contains a README file that's worth reading. In the next video in this DNS series, we'll add forward and reverse lookup zones, including A, CNAME, NS, MX, and pointer records. We'll also cover zone transfers between DNS servers. I hope you enjoyed this video, found it helpful and informative. If you have feedback, corrections, or suggestions, please share them in the comments below. Please like, subscribe, and share this video with others. Thank you for watching. I truly appreciate it.